Today we're going to work some more magic with variables. In the past, in the last couple of lessons, we've seen um, basically equations that were made or expressions, and they only had really one variable. And today we're going to look and see how we can have expressions and equations that actually have two variables. And I am going to teach you how to predict the future. See, you already have a head start because you knew what I was going to say. So, hey, that's creepy. What am I thinking right now? No, I was thinking about cheeseburgers, but whatever. Okay, so no hush, but you're close. All right, so here's what we're going to be doing. First of all, this should look familiar. I think it was back in I don't know. I know it was chapter one, maybe lesson one. Actually, I think it was chapter one, lesson one, when we were talking about patterns and identifying patterns. Gary, I need you to eyes up here. Chapter one, lesson one, like the very first week of school, we did a lesson on looking at and identifying patterns, and I said that's I remember saying that is a really important strategy or skill to have when we're dealing with really any type of math because it comes up quite a bit. So what I have here is an incomplete table. Um, I have x and y, and these guys correspond with each other. Say that word, correspond. Okay, correspond. Anybody have an idea what that means? What do you think? They work together. Yeah, they kind of work together. X corresponds with Y, and the values for X include 3, 4, 5, 6, 7, and then we skip to 10 for some weird reason, and I'll explain that later. And then the values for Y are 7, 8, 9, 10, 11. Now, these two numbers, for example, 3 and 7, they correspond with each other. Okay, 4 and 8, they correspond with each other. 5 and 9 correspond, and so to establish and to identify patterns, we need to take a look at corresponding numbers and try to figure out what's going on. Now, there's no simple way of doing this other than a little bit of trial and error. Okay, don't pre-number your work. This is not a spelling test. How many times do I have to say that? You just need to give me your attention. Okay, so let's take a look at what could be going on here. Okay, I have three. When I have three, y equals 7. Now notice already we're dealing with two variables. It's not just one. It's not just x. It's x and y. Okay, so let's take a look at what we have. We've got when I have 3, y is 7. When x is 4, y is 8. When x is 5, y is 9. When x is 6, y is 10, so on and so forth. And then what we're trying to figure out is what is y. Okay, what is y when x equals 10? Well, the first thing we need to do is we need to develop like an expression or an equation. Really, is what we're looking for. An equation that represents what's going on. Now, who can tell me? Just raise your hand if you think you know what's going on in this pattern in this box. James, what do you think's going on? Yeah, but what is the relationship between x and y? Like, let's take 3 and 7. Is there anything I can multiply by 3 to get 7? We can. I mean, we're allowed to do all of those things, but we need to ask ourselves what is it that happens when we have 3 and we end up equaling 7? What do we get? Yeah. All right, right. Okay, so you're right. I'm seeing this that I'm adding 4 right here. Now, that by itself doesn't mean that we've established anything because that might not work. A pattern is a predictable, consistent um, way of doing things. Okay, so if it works for one, it should work for all of them. So let's take a look at this. 4. If I add 4 here, do I get 8? Yes. If I add 4 to 5, do I get 9? Yes. So is it clear that our pattern is plus 4? Okay. Now, how could we write this out? You guys all see that, correct? Yes. Alyssa, you see that? That whatever we have with x, I add 4 to it, and I get what? So how can I write an equation that shows exactly what I just said. Try that out on your board. Let's just see, you might be right, you might be wrong, but just on your whiteboards, create an equation that would represent what is going on in this table. Then we can start predicting the future, which you know Tyler already knew I was going to say. All right. So I see. I'm going to just write down some of the things that I see here, okay? And then we're going to look at another table. I see x plus y equals 4. Okay. I see x plus 4 equals y. I see x plus 3 equals 7. My board's up. I want to see what you have. Right or wrong? I want to see what you guys have. I'm looking for. Okay, y plus. Okay, this is another one. Y plus 4 equals what? X. Okay. Um, X. What the heck is that? Y equals X plus 4. Okay. Equals X plus 4. I think we have that. I think it's just kind of reversed somewhere. And then we have Y times X times Y equals A. Oh, that's interesting. So, hey, so far we have a plethora of different equations. And I will tell you the right one is on here somewhere. We just have to weed through the errors and see which one. First of all, how did I get? Let's take let's take 7. Y equals 7, right? How did I get 7? It started off with 3. So what did I have to do? What? I had to add 4. Add 4 to what? To Y? If I add 4 to Y, I'm going to end up with 11. So I had to add 4 to what? X. So doesn't it make sense that if I take X, right, and I add 4, what do I get? Well, not all the time 7, because it depends on this variable, right? I mean, when we knew what the variable, if when we knew that X equaled 3, then yeah, that ended up being 7. But you can't put 7 down. Why could we not put 7 here? Why? 4 will always be a 4 because we're always adding 4 here. So I would say that the 4 is a constant. That is something that does not change. But what does change? That's what, hence the variable, right? What does change, Mikey? What does change, Mikey? Well, X and Y. Because the Y is dependent on whatever X is. You get that? So I'm not going to put anything as an answer because I don't know what this is unless I know what X is first. Does that make sense? So to solve our mystery answer here, okay, we're pretty content that this is going to be this is going to work, right? So here's what I do. I take now what is X in this box? What is that? X equals what? So let's put that value in our equation. On your whiteboards, do that right now. On your whiteboards, go ahead and put that value in your equation. I want to make sure you're doing the right thing. We think we've got an equation that will work. I agree. Okay? I know. Well, then share a marker with someone, but. All right, good. So I'm seeing that people are putting the 10 in the X place. And with that, we're gonna add 4 to it. So that means that Y is going to equal 14. See, we don't know what Y is going to equal unless we get X figured out first. Okay? Unless we give a value for X. Order of operations will have a role in just about everything we do. So yeah, what if I was to continue this? And this is where we're going to predict the future. If x equals 21, can you tell me what y is going to equal? Write it down on your whiteboards. Way to be a problem solver there, Mikey. All right, boards up. Let me see what you have. No, no, no. It's not x plus 4 anymore because we know what x is. What's x? 21. So now basically it's 21 plus 4. 4 is that constant. We're going to add 4 every single time, and that means that y is going to equal 25. Okay? See how that works? All right, now that one, let's say goodbye to. Goodbye. All right, now look at this. Now I'm really going to tweak your little thoughts. Okay. We have a new table. Different things can be happening to the table at all times. Our first y value is we don't know. We don't know this value and we don't know this value. Okay, but we have a lot in between, don't we? Okay. Why don't you guys right now on your whiteboard see if you can develop an equation? Put your hand down. See if you can develop an equation using two variables to describe what's going on in this table. Okay? So you're going to do something is happening to x to get us y. Okay? What is it? And write an equation that would show us this. Well, no, I can't. You can sit up closer, but I mean, James, you need to do something about those glasses, buddy. Yeah, that could really help you out. I've seen like miracles happen when somebody. All right, now, we adding 15 every time? No. All right, most of you, I'm seeing something like this. You're realizing, okay, we can look at this first. 4 turns into 16. Well, in the last one, we used addition, right? So maybe we're adding 12 because wouldn't plus 12 get us 16? 4 plus 12, would that get us 16? Yes, it would. Okay, cool. So let's look at that. What if I add 12 to 5? Do I get 20? No, I get 17, right? So right away we have a break in what would be a pattern. So it's obvious that we're not adding 12. There's really only one other way that we can have 4 and somehow get 16 out of it. And what is that? We're multiplying by 4. And then I multiply 5 by 4 to get 20. I multiply 6 by 4 to get 24 and 8 by 4 to get 32. So it's obvious that whatever we're doing with x, okay, if we multiply it by 4, we get what? We get y. That makes sense to you? Now, by the way, I see some of you like this. Some of you have gone x times 4 equals y. That's okay. Um, in fact, I see that quite a bit. I see this too, x times 4 equals y. This gets kind of creepy because we have two x's right next to each other, and it's like, what's that? My preference, my preference would be that you guys would write it out as 4x equals y. That's the more algebraic-y way of doing things. Okay, so this is our equation. Now, do we know what y is going to equal? If x equals 1, class, what is y going to equal? Just tell me. Right, because I plug in 1, 4 times 1 equals 4. Yeah. So now can we predict what 10 is going to be? 40, right, because whatever is in x, I'm going to multiply by 4 to get y. Okay? See how that works? Cool. Okay, let's practice some more on that. The other thing that you're going to see in this lesson is when you're given basically an equation in word form. Okay? This had to do with geometry. You think, well, what does geometry have to do with algebra? Well, sometimes it has everything to do with algebra. I told you at the beginning of this year, algebra is going to find its way in every unit of study that we have with math, whether it's geometry or measurement or, I don't know, whatever else we're talking about. Algebra will find a way. Okay, so here we have a sentence that says the length of a rectangle is 5 times its width. Let's think about that. The length of a rectangle is going to be 5 times its width. Rectangles are pretty simple. They're just little quadrilaterals. We'll talk about the definition of rectangle. Everybody thinks that rectangles always look something like this. They don't always have to, but we'll get to that at another time. Depending on how we look at this, I think we better be consistent with this. This would be its width, and this would be its length. Okay? So a rectangle has a width, it has a length. Now, can we come up with an equation that would work with this? Let's think about that. The length of a rectangle is 5 times its width. Why don't you play around? Play around with these words and these numbers. You're going to need a couple of variables, maybe L and what? W, right? You know that we're multiplying something by 5, and you know that there's going to be an equal sign somewhere. So why don't we take all those pieces? Okay, we got a multiply, we've got an L, we've got a W, we've got a 5 somewhere, and we have an equal sign. Okay, why don't we take all of those components and see if we can put together an equation that would work and would work every single time, no matter what it is that we added. Okay, get to work. Let's go on your whiteboards. On your whiteboards. Okay, so boards up. Let me see what you guys have. All right, I see you have 5 times W equals L, and then I see 5 times L equals W. L times. So I'm looking around, and that's pretty much the only two versions of what we have. Now, let's go back to the equation and figure out which one of these is correct. Because one of them is, the other one's not. Okay? The length. The length of a rectangle is. Now, guys, is a math word. It's a little word. Sometimes it doesn't mean anything in math, but a lot of times it means a symbol. What is it? Listen carefully. If I say 9 times 2 is 18, what does is mean in that? What? It means equals. 9 times 2 is. Okay? Hear that? So is means what, guys? It means equal. Okay, so let's build an equation. It says this. The length, that's L, is, pay attention, equals 5 times its width. See how we just were able to just put that all together? Now look at what you have. Christian, look at what you have. Is that what you have? A lot of you multiplied 5 by L to get W, but that wouldn't make sense because which one's going to be bigger, the length or the width? The length is going to be bigger, and how much bigger? 5 times bigger. 5 times bigger. So if I said, okay, the width of my rectangle is 2, then what's my length going to be? If W equals 2, then what's my length going to be? 10. If W equals 5, then what's my length going to be? 25. If W is going to equal 10, what's my length going to be? You see, it's almost like what I'm thinking of is like a photocopy machine. You know, if or like let's say that you've got a photo that you took on your phone or something like that, and you want to get like an enlargement of it because who wants like a little tiny picture, right? You want to make it a big picture. If you enlarge the width, isn't the length going to be enlarged as well? Yeah, it better. And we'll talk about proportions and things like that later on, but it just makes sense. Okay, so let's look at this problem. Now go back to 106, page 106. And let's see if we can't do this one together as well. Number 3, it says Jen is 6 years younger than her brother. So what I want you to tell me, what I want you to show is what what equation could we write that would illustrate that? Jen is, hey, what do you think would be a good variable for Jen? J, okay. And what do you think would be a good variable for her brother? B, all right. So we know that there's J, we know there's an equal sign, we know that there's what? 6 years younger. What could we do? Let's build this equation based on what's there. Now let's read that carefully. It says, yeah, where's yours, Michael? Come on. It says Jen. Now, what is there a little magic word right there afterwards? Is, there we go. Jen is 6 years younger than her brother. You got to be careful. You got 5 there somehow. 6 years. So we would take brother's age and do what with it? Add 6, multiply by 6, subtract, divide by 6. What should we do? Subtract by 6. And that's going to give us Jen's age. If her brother's 10, how old is Jen? 4. If her brother's 100, how old is Jen? 94. Okay, see, it doesn't matter. In other words, it doesn't matter. Like, you are older or younger than your brothers or sisters. Like, if you're 2 years older than your brother, he's never catching up with you, okay? I mean, you're always going to be 2 years, your age will change, but your brother's always going to be 2 years younger or older or whatever it was that I just said. Okay? Make sense? Okay, so part of what you're going to do today is work with some of these facts and figures, okay? And working with sentences and creating equations in its place.